Yes, gold can be created from other elements. But the process requires nuclear reactions and is so expensive that you currently cannot make money by selling the gold that you create from other elements. All regular matter is made out of atoms. All atoms are made out of a small nucleus containing protons and neutrons bound together, and a large cloud of electrons bound to the nucleus. Since most of an atom's physical and chemical properties are determined by the number and shapes of its electrons, and since the number and shapes of its electrons are determined by the number of protons in the nucleus, the nature of an atom is largely determined by the number of protons in its nucleus. All atoms with the same number of protons in their nucleus behave almost identically. For this reason, we call a group of atoms with the same number of protons a chemical element, and we associate various properties with particular elements. Gold is the chemical element with 79 protons in each atomic nucleus. Every atom containing 79 protons is a gold atom, and all gold atoms behave the same chemically. In principle, we can therefore create gold by simply assembling 79 protons and enough neutrons to make the nucleus stable. Or even better, we can remove one proton from mercury, which is 80, or add one proton to platinum, which has 78, in order to make gold. The process is simple in principle, but hard to do in practice. Adding or removing protons from a nucleus are types of nuclear reactions. As such, no series of chemical reactions can ever create gold. Chemical reactions change the number and shape of the electrons in an atom, but leave the nucleus of the atom unchanged. The ancient alchemists' dream of creating gold by simply reacting chemicals is therefore impossible. You have to use nuclear reactions to create gold. The difficulty is that nuclear reactions require a lot of energy. The nucleus of a stable atom is very tightly bound together, so it is hard to get anything permanently into or out of the nucleus. To induce a nuclear reaction, we have to shoot high-energy particles at a nucleus. We can get such particles either from radioactive decay, from nuclear reactions in a reactor, from the acceleration of slow particles, or from a mix of these techniques. For example, Scher, Bainbridge, and Anderson created gold in 1941 by shooting neutrons at mercury. The neutrons were generated by a series of nuclear reactions that were kick-started by the Harvard cyclotron particle accelerator. Usually gold is created from platinum, which has one less proton than gold, or from mercury, which has one more proton than gold. Bombarding a platinum or mercury nucleus with neutrons can knock off a neutron or add on a neutron, which through natural radioactive decay can lead to gold. As should be obvious by this production process, much of the gold created from other elements is radioactive. Radioactive gold is hazardous to humans and cannot be sold commercially. Furthermore, when radioactive gold undergoes radioactive decay after a few days, it is no longer gold. Therefore, in order to create non-radioactive gold that you can sell to consumers, you have to build a nuclear reactor to act as your source of neutrons. Place mercury in the reactor. After a large amount of work, only a tiny portion of gold is created. Decontaminate the resulting gold. This is harder than it sounds because you can't separate out non-radioactive gold from radioactive gold using purely chemical methods. It should be obvious from this process that it currently costs much more money to create non-radioactive gold than you could ever earn by selling the gold. Creating gold from other elements is currently an expensive laboratory experiment and not a viable commercial activity. Perhaps technology will improve enough in the future to make creation of gold in nuclear reactors a profitable economic enterprise.